Hello everyone. Today we will discuss how to do the rollback of a deployment in Kubernetes. So we'll simulate a scenario where we will be rolling back. So what we'll be doing is, let's say we have created a new feature. We have added a new feature into our system. So here I'm using example of Spring Boot application, but it could be any application. And now let's say that new feature has a problem. It has either a bug, or it is not working the way it is expected to be working, or it's throwing some unknown exceptions. So in our example, we'll be creating a new controller, and that controller will have method that controller will expose an REST API with the /new feature. And if anyone invokes that, it is going to throw an exception. It does not do anything, just throw an exception to simulate a rollback scenario. And if you want to see the code, this is the code. So this controller has only one method, which is exposes a REST API, and it just throws an error. So what we are going to do now is we are going to we have deployed this application already. In the last session, you saw that we have deployed this application. Now we are going to change this to version 3. Now, once you add this feature, then you have to build that. See, deployment is deployed with an old version. Now you have to build an image of your application with the new version. When I say image, I mean Docker image. And let's say we are giving version 3. So I have built that image already. So let me show that to you. So I have built this image, Docker version 3, Docker image with version 3. I hope you remember how to build a Docker image. It's Docker space build space -t, then your image name, then :3 is a version. So that's how you build it. Because I've already built it, so I am not going to build it again. Also, you saw that this deployment tips app is already existing, so it has replica set of replica 3. So all 3 pods are up and running. So what we are going to do is we are going to upgrade this to version 3 in the existing deployment itself. So let's see that. kubectl set deployment tips app set image deployment, set image deployment, and the name of the deployment, which is tips app. So this is the name of the deployment here, tips app. Then in this deployment, it has image. This deployment is done using an Docker image which has this container, and for this container we are going to upgrade the Docker image to latest version. So tips app container, and then here I had latest, so I will change it to 3. So before I submit the command, so immediately after we do this, we will see the pods upgrading to the new version, and we will see the the age also of the pods. So let's see that. Update it. So kubectl get pod, and so it's still getting updated. See, 7 seconds before this came, and this is was done 9 days before. And why there, when we have given replica 3, why there are 4, we will discuss in the coming slides. Okay. So another one got created. Slowly, all this will be using the, so these 3 are created, and the last one should go away now. So there are 3 with the latest hash. You see, earlier hash was this. We discussed hash, this hash. See, earlier when we started, all 3 replicas were using this hash. Then the new image had this, the new port template has this hash. So eventually you will get all the ports with this hash. Now we'll follow the slide. So we can log on to one of these pods and try to invoke. We don't need to log on, we can invoke him from outside. Let's try that. kubectl exec, then this, correct, then hyphen bash hyphen. Instead of doing bash, because we are not going to the bash session using interactive mode, we'll be running some command, and what that command is curl localhost 8080 new feature. So let's see if that works. Cu curl local host colon 8080 slash new feature FATU. Let's see what it gives. So it gives an error. You see, it threw an error. In production, you will be getting, you should be converting this to through error, say damn ran into error, right? So you will not send this whole stack test to the user. You will send a user-friendly error message. But here, just for a demo purpose, so this damn into error, I'm getting it here. Correct. Now, so we know the new deployment has a buggy code, or the code which is not working the way it is supposed to be working. So what we'll do now is we'll be doing the rollout, rollback. Sorry, not rollout, rollback. So the command for that is kubectl rollout undo deployment tips app. So it will roll back to the previous version. So let's see. Okay. Let me do it here. kubectl undo. Sorry. kubectl rollout undo. ROLLOUT rollout undo deployment tips hyphen app. MENT tips hyphen app. Okay, the spelling was wrong, so let me fix the spelling. Okay, my mistake. Okay, kubectl. So it got rolled back. Now it got rolled back. So you want to check the history of the rollback, right? So this is the command kubectl rollout history. So kubectl rollout history, instead of undo, we'll do history. So excuse me. So you can see the if you want to roll back to specific version, so the command to do that will be kubectl rollout undo deployment tips app, same, then -f to -revision. So you can is going to change it to 3, which was the error version, but let's see that. Now we'll see the history. So let's change it to 1 and see what happens. Let's see the history. It's 7. So 1 has become 7 now. So my mistake. I was trying to read from bottom to up, and in reality it should be from top to bottom. So 5, 6, 7. Now 7, I want to change it to 5. Let's see. So roll back to 5. So now I do this history. So 5 has become 8, correct? So, but only the current and the last 2 are maintained here. You can check that out. Replica set also act as revision history. By default, only 2, current and the previous. See, in this case, our case, it was 3, current and previous 2 were maintained. So there is a revision limit history property in the deployment YAML or in the deployment setting. You can set that if you want more previous replica sets to be maintained. So, so how the revision history works is, so you have revision 1 of replica set, revision 2 of replica set, revision 3 of replica set, which are maintained by deployments. Now, so these are the, this is the latest revision, and the replica sets port for revision 1 not applicable anymore. So replica sets, once you upgrade, then this will not be applicable anymore, correct? For this statement, only 2, current and previous, are maintained. But in our case, 3 replica sets are maintained. For in our case, this will also be, this replica set will also exist with some pod associated with it in case we want to roll back. If there's a fourth replica set, or sorry, 0 replica set, the very first replica set division, let's say it was 0, so that will not exist anymore. That will not be applicable anymore. Control rate of rollout. So during rollout, a new pod was created, and after the creation of one pod, the older pods were deleted. So we saw that, right? So there we had 3 pods initially, and then let's see that here one more time. If I can show you that, see here. So replica number of replicas was 3, but there was 4th pod created. 4th pod also got created. So for some time, the 4th pod also existed. So now same cycle is repeated till all pods are on the new version. Now there are some questions you might ask. So what are those questions? Does only one new pod is created always before deleting one pod with old version? We had replica set 3. Why could we not create 2 new pods with a new version and then delete these 2 existing pods? So after that we'll have 2 new pods with the new version and old pod with the old version. Other question could be, can we create 2 new pods and delete one old pod? How such flow is decided by Kubernetes, and that is where these settings of max search and max available come into play. So this documentation I copied pasted from this link. You can go into this link also yourself and read in more details. So this max search is a property in the deployment. It comes under spec, strategy, rolling update, and max search, and it's an optional field. It specifies the number of pods that can be created over the desired number of pods. The next is an example. The value can be absolute number, for example 5, or percentage of desired pods, for example 10%. The value cannot be 0 if max unavailable is 0. The absolute number is calculated from the percentage by rounding up. If you give percentage and the percentage results in some decimal number, that it's rounded. Let's say it returns in 3.7, it will round up to 4. And the default value for this is 25% percentage of desired pods. So take an example. When this value is set to 30%, when max search is set to 30%, the new replica set can be scaled up immediately when the rolling update starts. Such that now when the new replica sets can be scaled up to what pods, what number of pods? They can be scaled, and remember this max search is 30%. Such that the total number of pods and the total number of old and the new pods do not exceed 130% of desired pods. So now you can see an example. If we have 3 replicas and we set this value to 30%, so total will be 130% of 3 replica is 3.9 or something. So which we round it up, so it becomes 4. So the total number of pods cannot exceed more than 4 at one point of time, and those total number of pods include the old pod and the new pod. Old pod with the current version and the new pod with the new version to which we are trying to update to. Once old pods have been killed, the new replica set can be scaled up further, ensuring that the total number of pods running at any time during the update is at most 130% of the desired pod. So that is during the upgrade. What is max unavailable? Max unavailable. So this is also an optional field. It specifies the maximum number of pods that can be unavailable during the update process. See, right now we discussed how much more pods you can create. So if you have replica 3 and 130% is the max search we have given, you can go up to 4, 3.9, which rounds up to 4. But there is another setting called max unavailable. If during the upgrade, the Kubernetes decide based upon your settings that it needs to, instead of 3, can it be 2 or can it be 1? So that you can decide. So how do you decide that? You decide that based on this max unavailable setting. So, so again, like in max search, this number could be absolute number or percentage of desired port. For example, 10% you want out of, uh, whatever total number of ports are available, you can manage with 10% can be unavailable. So absolute number is calculated from the percentage by rounding down. This number cannot be 0, and the default value is 25%. Now let's see. For example, when this value is set to 30%, the old replica set can be scaled out to 70% of the desired ports. So our desired ports are 3, and 70% of 3 is 2.1. So we round it down here in this case. So you can have up to 2 ports, max unavailable ports can be up to 2 ports. Once the new ports are ready, so this is the same thing. Once new ports are ready, all replica sets can be scaled down further, followed by scaling up the new replica set, ensuring that the total number of ports available at all times during the update is at least 70% of the desired ports. So 70% is the max, available at all times. So, my mistake. So when you have 70%, so 70% is availability. So 70% of 3 is 2.1, which rounded down to 2. So 2 are available, 1 need not be available. Out of 3, 1 need not be available, 2 have to be available at all times. So that's so one way to explain this would be forget about max search, focus only on the max unavailable property. So if max unavailable property you have given 30% and replica number of replica is 3, sorry, you have given 70% and number of replica is 3. So which means that at any point in time, your 70% is when this value is set to 30%, the old replicas can be sold out to 70%, correct? So we are going with this example, 30% and old replica can be scaled down to 70%. So you're given this value as 30%, and the old replica set can be scaled down to 70%. So if the number of replicas is 3 and you are scaling down to 70%, which is 2.1, and rounding it down, it becomes 2. So, so 2 have to be available at all time. So you can, you can do your homework. So you can write and validate the deployment with max search and max available properties, and you can read about, more about this on this blog. So this is a blog. Very nicely explained about these properties. So you can pass the rollout also. So what do you mean by you can pass the rollout? This is the command to pass the rollout. kubectl set image deployment name, container image. This is the image you are setting. So if you see the help of kubectl set image deployment help, you can see update existing images of resources and possible resources. You can update of port, replication controller deployment, daemon set, stateful set, cron job, replica set. And if your image has multiple containers, because that's how you've created the image, then you can set the each container image separately also. So this is the help you can see from your command line. So the process to pause is kubectl rollout pause deployment and tips app, and you can resume using this command kubectl rollout resume deployment tips app. And why do you want to pause it? You want to pause it because you want to test new version on certain few nodes first, and then on the few ports first before you roll it out to everyone. That's one way to handle the rollout process. Or there are tools like Argo CD, which can be used for this purpose. So in Argo CD, you can control the deployment. It gives you very nice graph, and you can see what are the ports having the new version, what are the ports having the old version, and you can control all of that. And then once you're happy, then you can deploy the new feature or new image on all the ports. So Argo CD also helps you to do that. You can block the bad versions when a buggy pod is getting ready. Then there is a setting we discussed. Min ready seconds is a time till which the pod readiness is awaited, and there's a readiness prop. So it's used to check if app is ready before the min ready second time. So let's say min ready cycle time is you know 10 seconds, and in readiness pros you have given the URL, let's say new feature URL, and readiness probe will check that and get an exception, and that is before this min ready probe. So when that happens, then pod is not considered ready and it won't be made live and will be rejected. But you have to set this up. There are some additional rollout config. By default, after the rollout, can't make any progress in 10 minutes, it's considered as failed. So if you're, if you have done the rollout and there is no progress in the ports, because of whatever reason, the something has gone wrong, and in 10 minutes there has not been progress, the ports are not getting updated to the latest version or image, then it will be considered as failed. And you can see the kubectl describe deployment command. This is command, and it will show you the progress deadline exceeded condition. The deployment has not gone through because the deadline of 10 minutes got exceeded. And you can set this progress deadline in seconds in the deployment YAML also. So if you don't want 10 minutes, you want 1 minute, 5 minutes, or 20 minutes, you can set that up. So within that time, if the pod is not getting updated, it will be considered as failure, and this happens during the rollout only. So that's about the rollout, the deployment and the rollout, and the various versions, how this get updated, how to block, how to do rollout to specific versions. So thanks for watching. Next time we will start about the stateful applications in Kubernetes. So far what we have discussed is all the application when pod crashes and new application comes. It doesn't need to maintain any state. So new application comes without any consideration about state. But what if you build stateful applications? Most of the time stateful application means you are maintaining some class level variable or some state in your application in the memory, and once your pod goes down, you lose that state. So now how to bring the new pod, how to design such applications where you take care of this state management of the pod, so that when the existing pod crashes, the new pod comes up and the state management gets taken care. So we'll discuss that in the next session. Thank you for watching.